First, we will give a brief overview of the background info for this experiment. In this experiment, we will learn to recognize different types of chemical reactions by investigating a sequence of reactions, beginning with aluminum, metal, and ending with potassium, and identify the reactions involved. The term alum is a general family name for a crystalline substance composed of cations with 1 plus and 3 plus charges. We will synthesize a type of alum called potassium aluminum sulfate dodecahydrate, which this is the chemical formula for that. To synthesize this compound, we will place the appropriate ions in one container in an aqueous solution and then evaporate the water to form the alum crystals. The compound potassium aluminum sulfate dodecahydrate was chosen because it is relatively straightforward to prepare a pure sample. This process of synthesizing not only involves chemical reactions, but physical reactions as well. In a chemical reaction, aluminum is oxidized from aluminum foil to prepare the aluminum 3 plus ions. Through the physical reaction, the solution that contains the mixture of ions evaporates and crystals containing 6 waters of hydration bonded to the aluminum ion and 6 waters bonded to the potassium ion are formed.
Now for the background information of aluminum. It is considered a reactive metal, but due to its surface, which is usually protected by a thin film of aluminum oxide, it reacts slowly with acids. However, it does dissolve quickly in basic solutions. The excess hydroxide ion converts the aluminum to tetrahydroxide aluminate 3 ion. By slowly adding an acid, a white aluminum hydroxide forms. By continuously adding the acid, the hydroxide ion becomes completely neutralized, and the aluminum exists as the hydrated ion. This is the formula of the hydrated ion. Neutralized means a strong acid and strong base chemically react to form water and a salt. Since aluminum hydroxide dissolves in acids and bases, it is known as an amphiphotaric hydroxide. According to the World Commission of Environment and Development, says it is important to recapture and reuse raw materials and products when we don't want the products anymore. Aluminum is a great resource to recycle. The major ore of aluminum is bauxite. By recycling an aluminum, we extend the lifetime of known reserves and lower the cost of aluminum. It also limits the environmental damage associated with mining bauxite.
While the best for use of aluminum cans is to recycle them as cans, they may also be used to produce other useful products. For example, the alum KALSO4 times 12H2O, the chemical used in dyeing cloth, can be made from aluminum cans. Aluminum is easily separated from iron since aluminum, but not iron, dissolves readily in hot aqueous potassium hydroxide, based on this equation. When you add the sulfuric acid, the precipitate AlOH3 is formed, but when added to hot water, it dissolves, giving you this equation.
So coming from the previous equation that Abby told us about, you get this. And then after cooling, aluminum forms according to this equation. And then the overall equation of the formation of aluminum from aluminum is this.
The first thing you'll do in this procedure is add 0.5 grams of aluminum scrap that is cut into small pieces to a large 200 milliliter beaker. Take the beaker to the fume hood in order to add 25 milliliters of 1.5 molarity potassium hydroxide. After that, heat the beaker on a hot plate for approximately 30 minutes or until the aluminum is completely dissolved. When the heating is done, remove it with tongs and remove the small pieces of aluminum. Get a piece of filter paper and place it in the funnel. After you funnel the solution, let it cool for 5 minutes and then put it in an ice bath. Continuously stir and add 2 to 5 milliliters of non-molarity sulfuric acid, or until the pH volume is between 1 and 2. Next, heat for 10 minutes at 60 to 80 degrees Celsius, or until the aluminum hydroxide dissolves. If you need to, continually add drops of sulfuric acid until the pH level is between 1 to 2. Don't heat for more than 20 minutes, then remove it from the heat source. Place the same beaker in an ice bath for 20 minutes so the crystals can form. Then use a Buckner funnel to vacuum filter it. Take the crystals and lay them out to dry, and then weigh it.
Our starting mass of aluminum scrap is 0.524 grams, and we add hydrogen sulfate to make a pH of 1 to 2. The precipitate, aluminum hydroxide, appears, and then we add heat, and the aluminum hydroxide dissolves. The filter paper weighed 0.38 grams. The filter paper with the watch glass weighed 57.11 grams. The watch glass with the crystals inside of it weighed 61.41 grams. The mass of crystals is 61.41 minus 57.11 equals 4.3 grams of aluminum. The number of moles of aluminum we began with. We took the 0.524 grams of aluminum that we came up with and divided it by the molar mass, which is 26.92 grams, and came up with 0.0194 moles. To come up with the number of moles of AO recovered, we took 4.3 grams of aluminum that we came up with in our experiment and divided it by 474.39 grams of aluminum, which is the molar mass, and then multiplied it by 2 moles of aluminum and divided by 2 moles of the aluminum to come up with 0.009 moles.
You take the original amount of your aluminum that you started off with, divide it by the molar mass of aluminum, and then take the numbers in the chemical equation, and then multiply it by the molar mass of alum. And when you do that, you get 9.209 grams of alum.
To find the percent yield, you take the actual yield divided by the theoretical yield and multiply it by 100. In this case, you get 4.3 grams divided by 9.209 grams times 100 equals 46.69%.